Let's write this equation. First, nitrogen. These are all gases. Let's see, we gotta balance this first. Balance this first. All right, let's do some stoichiometry with these numbers. If we start with 15 grams, 15.0 grams of nitrogen, first step in stoichiometry is to convert that to moles. So molar mass of nitrogen is 28 point. You know what? We better use 4 digits here. 14 right there. 14.01 times 2 is 28.02 grams per mole for N2. Since we're already here, let's do H2. All right, so hydrogen is up here. 1.008 times 2 is going to be 2.016 grams per mole. All right, so we got the hydrogen, because we'll probably have to do that later. The molar mass for nitrogen and the molar mass for hydrogen. Right, so now we can convert this to 28.02 grams of N2 are in 1 mole of N2. Units cancel out. Now we're going to use the mole ratios to convert to the desired substance. So the mole ratio is 1 to 2. And, oh, hold on, let me see what the question is. So asking for moles. Oh, grams of ammonia. All right, let's do that too. Do ammonia here in green. All right, ammonia is NH3. So that's going to be 14.01 plus 3.024. I just multiply that by 3. So that's going to give us 17.03 grams per mole for the molar mass of ammonia. All right, so let's convert that. Moles of ammonia to 17.03 grams. All right, cancel this out. Punch these numbers in. All right, just pause the video for a few seconds. I had to all right, anyway, so I punch these numbers in. I'm going to get 18.2 grams. Let's label that. All right. All right, that's how much we could get if we started with 15 grams of nitrogen. Now let's see how much we can get if we start with 15 grams of hydrogen. 15 grams of hydrogen. All right, so what did I use? Blue. 15 grams. Go back to blue. All right, again, the first step in stoichiometry is going to be convert to moles. So we need a conversion factor to get rid of grams of hydrogen and turn that into moles of hydrogen. We did this earlier. It's 2.016. Just make sure. Yep. Right, now we have moles of hydrogen. Now we can turn moles of hydrogen to moles of any other substance using the mole ratio. Right, so moles of hydrogen, I think that was 3, and then there's 2 moles of ammonia. For every 3 moles of hydrogen, there are 2 moles of ammonia. Every 3 moles of hydrogen, there's 2 moles of ammonia. All right, that cancels out the unwanted stuff, and now we just need to convert that to grams. All right, so we can just copy this over here. That's often going to be the case. All right, last step, convert to the desired unit. All right, let me punch these numbers in. 15 divided by 2.016 times 3 divided, times 2 divided by 3 times 17.03. Wow, that's a big number. Much bigger than the grams of ammonia. All right, let me punch these in again. Well, does it make sense? Well, it does, because you're going to have way more moles of hydrogen. Hydrogen is way lighter than nitrogen, so that does make sense. Okay, so we're probably fine. So what is the percent yield of this reaction if 10.5 grams is produced? 10.5 grams is produced. That's the actual. All right, so which one of these is going to be the theoretical? Right, is it going to be the 18 or the 84? All right, we're definitely not making 84 grams of ammonia because we don't have enough nitrogen. So this here is, by the way, called the limiting reagent. It's going to limit how much we can make. All right, and so this here is called the theoretical. All right, that's if this ran to like this, if this reaction happened perfectly, and we would get 18.2 grams. So that's the theoretical goes on the bottom, and the actual goes on the top. All right, so it's actual over theoretical times 100, and you get your percent yield. All right, so the actual, I think it was 10.5 is what it said. All right, so actually the reaction only made 10.5 grams, but we could have made 18.2. All right, now things are never 100%. There's always errors or contaminations or things that happen. So, all right, let's multiply that by 100 to turn that into a percent value. 10.5 divided by 18.2 times 100, you get 57.7% is the percent yield.